Oh, one more missing. Didn't come back yet. Okay, never mind. Okay, never mind. Right? No, two missing, not one, two missing. Okay, right. So now I was explaining halfway about this isosceles triangle constructed inside the sector. And this isosceles triangle, I cut into two right angle triangle. So when I cut into two right angle triangle, I use the sine ratio. So AD divided by AC is the sine of the angle, half the angle at the center here, half the angle at the center. And I found out to be 1 over root 2. 1 over root 2 is 45 degrees. You have to remember this, chapter 5, form 3, chapter 5, form 3. So 1 over root 2 is 45 degrees. Then, but 45 degrees is half of this angle. The full angle you have to multiply by 2. That means the whole sector here, you have to multiply by 2, which is 90 degrees. So you want to find the shaded area in units. Shaded area is this purple part here. Okay. Now for the purple part, how to find? You look at this thing here. Shaded area is the area of semicircle AOB minus segment ABE. Now you look at this semicircle here, this semicircle. So you use the area of this semicircle minus the area of this white segment, this white color segment, and you will get the shaded area. Okay, so can follow or not? Chen Tong. Chen Tong. Can.
Teacher,
Yes.
for the question B, the sin angle ACD equal to 5 over square root 50. That one is a formula. What formula?
ACD. Okay, right. Let me explain, right? So this is an no. So this is an isosceles triangle. Is an isosceles triangle like this, right? Then I use this one. I pull down the right angle here. So this one becomes a right angle because this one is the radius. This one is the radius A, right? Okay, right. So this one is A, then this one is it C or not? Is it C? Number 4. Number 4, ACB. Number 4, ACB. Okay, A, this is C, so this is C, this is C, then this is B. This is ACB. Then this one is D. This one is D. Okay. So can you see this thing here? This one?
Yes.
Yes. So this actually not, I simply draw like that, not very isosceles. Actually it's isosceles lah. Now what I want to do is this number here, I found out to be this I found out to be 5 cm because it is the radius of the circle. I found out to be 5 cm. Then this length here, this length AC is, I use the formula for distance between 2 points. I found out to be square root of 50, not cm, unit, sorry, unit, square root of 50 units. This one from the distance formula, this one unit, this one is from the radius of the circle. So is this okay so far? Do you know what I've written here? 5 and the square root.
Yes.
Yes. Now this angle here, right? This angle here, this angle here. Can you see this angle here?
Yes.
So this is the angle that I want to find. And how to find this angle? How to find this angle? I use trigonometric sine. Sine of this angle here is 5 divided by square root 15. This angle, half of it. Now the other half, there's another half here. There's another half there. There's another half here also same, because this is an isosceles triangle. So the other half also same. If this is 45, this is also 45. So is 5 divided by square root 50. I use the sign. And I found out to be 45. So the other one also 45. So becomes 90. So the whole angle here, becomes 90. The whole angle. The whole angle here becomes 90. Okay or not? At first it's 45, then the whole thing become 90. Okay, right. So now in order to find this purple color part here, I use the area of the semicircle minus the area of segment. How to find area of segment? Do you remember the formula for area of segment? Yes. Area of segment is half r square theta minus sine theta. Right? So half r, I found already, this r, the radius of the sector, square root of 50. Then r square is square root of 50 square. Then bracket theta 90 degrees is pi over 2, right? I told you already. Theta, you have to be in radian. 90 degrees in radian is pi over 2. Then minus sine of the angle, sine of this angle. Now this segment here is actually referring to the white color here, the white color. So I use the area of sector minus the area of this right angle triangle. So area of sector minus the area of right angle triangle. So simplifying, I have pi bracket, 25 bracket pi over 2 minus 1 unit square. Okay, right. So this is the area of the white segment. Any question? Any
No.
question? Area of segment?
No, teacher.
No. No, then now the shaded area. Shaded area is the semicircle minus area of segment. Semicircle is the other circle already. This circle here. The radius is not square root of 50. The radius is 5. So half pi r square. Pi r square is the area of the full circle. Half pi r square is the area of the semicircle. So area of semicircle minus the area of segment, right? Then you open up the bracket, you get this. And answer is 25. Exactly 25 units. Okay or not? Now I ask another girl. Zini, can or not? Zini. Can? Oi, Sarah, welcome back. Long time no see, Sarah. What happened to you? Can follow or not? Huh, Sarah? Can? Zini can. Sarah can or not? Long time didn't follow. Can. Okay. Sarah can follow already. Okay, next. Now, this is it. So Can I close down this one and start a new chapter? You can always refer to the video. Today I remember to record. So you can always refer to the video, and you still have questions to ask from this chapter, you can still ask me. Okay, can I close this chapter and start another one?
Yes.
Yes, okay. Oh, no. Okay, save changes, yes. Okay, now we can go on to a new chapter. So the new chapter is differentiation. Now before we do the actual differentiation and the applications of differentiation, you have to know what is limit, what is differentiation from the first principle, then the shortcut differentiation, right? Now when I say differentiation from the first principle, that means it doesn't mean that differentiation got first principle, second principle, third principle, and so on. Not like that. First means dari mula-mula, dari awal-awal. So first here means at the beginning. It doesn't mean number one. Okay or not? At first we have to do this, that. I mean, at the beginning we have to do this, right? In the beginning we have to do this. So the first here doesn't mean number one. It means at the beginning. So differentiation from the first principle means you do differentiation from the very basic, from the very beginning. Okay, so it doesn't mean first method of differentiation. No. Right. So in order to know differentiation, you must know limit first. Then only we can proceed to first principle. Okay, right. Now, normally the limit, you want to find limit and so on, it cannot run away from this reciprocal function, the inverse function, which is 1 over x. Have you learned this function in your mathematics or not? Got no? Chapter Form 5, first chapter or something like that? No. Function, the different type of function, 1 over x, 1 over x squared, x cubed, and so on. Never mind. You never learn your mathematics. Okay, right. So we look at this function now, y equals to 1 over x. This one, y equals to 1 over x. Now, if the x approaches 0, wait, let me see. I'll move this thing over here. As x approaches 0, y approaches infinity. What does this mean? X approaches 0. Now, this arrow here, you read it as approach lah, approach. The basic word is approach. Since there's only one x, so we say x approaches 0. What does it mean by x approaches 0? That means x is not yet 0. X is a very, very small number. Smaller and smaller. It's getting smaller and smaller. What happened to the y? The y is getting what? Smaller and smaller or bigger and bigger? Right, you become bigger and bigger. Now, so when this x approaches 0, y becomes 1 over 0. If you substitute 0 in this function, it becomes 1 over 0. 1 over 0 is actually what? 1 over 0 is undefined. Undefined, that means we don't know the actual numerical value of this number. The actual, how much is it? Now, you say it's 1000. It's not undefined. 1000 is exactly 1000. Or you may say 1000, 2300.5. It is exactly that number. So it is not undefined. It's a real number. You can know the number. But when we say undefined, it means that we don't know the value of that number. We cannot find the value of that number. Or that is undefined. But in actual practice, this number is actually very, very big. Very, very big. How do we know it's very, very big? So now we look at this number. We start from 1. 1 over 1, this is x, the top line is x. The bottom line is y, which is 1 over x. Is that Sherwin back here already? Where is the Sherwin? Otherwise, you miss this or where is she? Sherwin, are you with us, Sherwin? Otherwise, you cannot. I didn't see the name here anymore. Oh, Sarah only. No more Sherwin. Is Sherwin with us here? I saw her just now.
No.
No, no, so you missed this part. This what is never mind. Okay, so now this number becomes smaller. From 1, I make it smaller, 0.01. Then I make it 0.001. I make it 0.0001. So what am I doing? I'm actually making the x smaller and smaller. So this is what I meant by x approaches 0. So far, can understand or not? Yes, this means x approaches 0. Now, as x approaches 0, we look at the value of y. Y at first is 1, then 100, 1000, 10,000. So if I go on, x becomes smaller and smaller. Y become bigger and bigger. It becomes 10,000, 100,000, 1,000,000, and so on. So when this x, which actually cannot be 0, which can only approach 0. So as x approaches 0, what happens to the value of y? The y becomes very, very big. And how big is that number? I don't know how big is that number. I only know that it is a very big number. So that very big number is called infinity. Now, infinity is actually not a number. It is just an idea. It's just a concept that something is very big there, right? Since we don't know exactly how big it is, so it is not a number. Infinity is not a number. And since we don't know the exact value, we say it is undefined. So can you see the difference between undefined and infinity? Undefined means we don't know what number is that, the exact value of the number. Infinity is an idea. It is a very big number, but we don't know the exact number. Any question? Any question? Undefined and infinity?
No.
No, you know what is undefined and what is infinity. And you know what I mean by as x approaches 0, y approaches infinity. As x
Yes.
approaches, y approaches. Okay, right. So now, this is the first thing you need to know. X approaches 0, y approaches infinity. Now we look at another one, right? Now, this still at the same function, y equals to 1 over x. Y equals to 1 over x. As x approaches infinity, y approaches 1 over infinity. Y approaches 0. Hey, what is this? We look again, right? We look again. Now, instead of making this x smaller and smaller like just now, I'm going to make this x bigger and bigger. So as x become 1, 10, 100, 1,000, 10,000, 100,000, 1,000,000, and so on. Well, what happened to the value of y? Value of y when it's 1, then is y is also 1. When x is 10, y is 0.1. So you go further, 0.01, 0.001, 0.0001, 0.00001, 0.00001. So what does this show us? It shows us that as x become a bigger and bigger number, y becomes smaller and smaller. And how small is this y? This y we know how small it is going to be. It is going to be 0. As you go on like this, smaller and smaller, it is going to be 0. And we say that y approaches 0. So as x approaches infinity. Now why I cannot say x equals to infinity? Why? Just now I told you the answer already. Why I cannot say x equals to infinity, y equals to 0? Why not? Anyone can answer this question?
Teacher, can you repeat the question?
Question is, you see here, x approaches infinity, y approaches 0. Now I know some girls, they are going to say like that. X equal to infinity, y equals to 0. Some girls is going to use the equal sign instead of approaches. Instead of the arrow, they are going to put equal there. Why is it that we cannot put equal sign there? Why is it that we have to put the arrow like that? Okay, so let me answer the question. You cannot put equal because infinity is not an exact number. We don't know the exact value of that number. Now, once you put equal there, it has to be an exact value. Infinity is not an exact value. So we can only say that x approaches infinity, nearer and nearer, closer and closer to infinity. That is like this lah. From 1,000, 10,000, 100,000, 1 million, 10 million, 1 billion, 1 trillion, like that. As you become very big like that, what happened to the y? Y will become 0, 0, 0, 0, 0, 1. Right? Or if you can put a number inside, then you can say it's equal, but you cannot put the number inside, and we are not going to put the number inside. We are going to say infinity. So when by the time x approaches infinity, y will be very insignificant. It will be 0 that time. We can say y is 0, equals to 0. Yes. Okay, right. Any question? No question, then I continue to tell this thing.
Okay.
Okay, now if you have a number divided by 0, then it's undefined. This number k can be anything, can be 0, can be 1, 2, 3, can be any number. As long as the number something divided by 0 is undefined. And as long as you have k divided by a very big number, it will approach 0, right? It will approach 0. Okay, right, next. Now we talk about limit. Okay, now we talk about limit. Now, how to find limit? I give you three general guidelines. As you go higher and higher, you may have other methods to find the limit, and really there are other methods to find the limit. So what we are learning now is just the basic only, right? If you are interested in mathematics or maybe some engineering or physical science, and then you will see that there are more methods to find the limit, right? I only show you three here. Okay, now the first question is, this is the function x squared plus 3x over x, and find the limit of fx as x approaches 0. Right, now you can always take the 0 and you substitute inside here. Now what happened when you take the 0 and substitute inside there? Substitute 0, so 0 plus 0 divided by 0, so it's 0 over 0. Now 0 over 0 is undefined. Now when people ask you to find the limit and you substitute the number inside and you find something like this, that means your method cannot be used. You have to use another method to find the limit. Now if you get something like 0 over 0 or infinity over infinity, you have to try other methods. Okay or not? When people ask you to find the limit, you put in the number and you get something like 0. Don't tell me it's 0, 0 divided by 0 is not 0. Or infinity divided by infinity, I cancel, then I get 1. It cannot be like that, right? Cannot be that. You don't go and cancel the infinity, you get 1. Or you cancel the 0 and 0, you get 1. That cannot. Once the 0 appear or the infinity appear at the bottom, there you cannot do anything, right? We try to do other method. So what are the other methods? What are the other methods? You try to factorize, or you try to divide by x, or you try to rationalize the function. Now you have learned about rationalization in Form 4 first chapter, I think, or third chapter, something like that. Before when you learn indices, first chapter is what? Function. Second chapter is what? Quadratic equation, quadratic function. Third chapter, I think, rationalization, indices, and logarithm. Okay? So you learn about rationalization. So generally at this Form 5 level, you want to find the limit, you try to use these three methods: factorization, divide by x, and rationalization. You only use these three when you get something like 0 or 0, infinity or infinity. If you don't get this number, you just substitute the number inside and you get the answer, and that will be the answer. You don't have to use these three methods. So far, okay or not?
So teacher means if we got the answer 0 over 0 or infinity over infinity, we must use another method.
Yes. But before that, you have to substitute first lah. You don't straight away try the three methods lah. Okay or not? Don't try these three methods first. You try to substitute in the number. Maybe you get a number, right or not? So try to substitute first. If substitution cannot, then you try these three methods. Okay. Okay, right. Okay, right. So we continue. So we are going to try another method, right? Because the 0 was 0, so I'm going to try another method. So this method is factorization, the first one. So I have this function here. I see that there is a common factor in front and at the back. This is x squared, this is 3x. So I can factorize out the x. So when I factorize out the x, it becomes x bracket x plus 3. At the denominator, the function is x. Okay. So when after factorization, I can cancel the x away. Cancel the x away. Then I have x plus 3. Now you can substitute in the number 0. 0 plus 3 is how much? 3. So the answer for the limit is 3. Now, this type of question they ever ask in the SPM or not? Yes. Once upon a time, this is in paper 1, a very small part, they ask this type of question. Okay, not? Very small part, 1 mark, 2 marks like that. They have asked before, but not every year they will say, oh, this year, sure they ask limit, we don't know, right? That one we don't know, but it is possible that they will ask you about limit. Okay, don't say, oh, this one limit, not important one, not coming up for the exam. It may come up. It has come up before. Okay, right. So you know what I mean by factorization or not?
Teacher, how to factorize?
Factorize means you make the bracket. You look at the function, the top one, you make a bracket there. Make a bracket. Bottom, actually this one, you don't have to make bracket lah. Some other question, maybe you need to make a bracket. So the factor at the top and the bottom can cancel away. Okay, you have to make the bracket, then the factor one of the factors can cancel away. So far, okay or not? Can follow? Follow, then I give more examples. This time got infinity, got 0.
Can teacher.
No, continue, right? Okay, then this one, move to another part. Okay, now we look at this example here. Find the limit when x equals to 4. Approaches 4, sorry. Limit of this function when x approaches 4. So when x approaches 4, it means the x here you substitute with 4. The x here you substitute with 4. See whether you can get 0 or infinity or not, right? So put in 3 minus square root of 4. Square root of 4 is 2. 3 minus 2 is 1. Then here 4. 4 plus 2 is 6. 1 over 6. Need to use the three methods or not? No need. This one very easy. You just substitute number inside, it works. Only when you substitute number inside, it doesn't work, then only you try other methods, right? Okay, now this is another question, right? Another question. So this question is find the limit as x approaches 1. What is the function? X squared minus 1 and divided by x minus 1. So now they say x approaches 1, so I substitute 1 inside. 1 minus 1, 0. 1 minus 1, 0. 0 divided by 0, undefined. So if undefined, what must I do? I try three methods. Factorization, right? Then rationalization, and so on. So the first one I want to try is factorization. So you don't know what is factorization? You look here. X squared minus 1 is x plus 1, x minus 1. Right? So I make two factors. But you look at the bottom there, hey, there's a common factor. So I cancel away. When you cancel away the common factor, you are left with x plus 1. So now can I substitute 1 inside? Okay. Substitute 1 inside, 1 plus 1 is 2. You don't get 0, 0. So you know what is factorization now, Li Ying? Do you know what is factorization?
Yes.
Yes, you know what is factorization, right? Okay, so this is the uh, first method, factorization. Of course, before the first method, you try to substitute directly first. Right? Substitute directly cannot, then you try the first method. So first method can, right? We're going to look at the question C. Now question C is like this. Square root minus 1 divided by x. X approaches 0. Now this x approaches 0, I always try first, put 0 inside first. Okay, x approaches 0, something wrong here, 0. This is 0, right? 0. So 0 minus 1 is 0 plus 1 is 1. Square root of 1 is 1. 1 minus 1, 0. Bottom also 0. 0 over 0, undefined. Okay, undefined. So you get 0 over 0 again. Try to factorize. Don't know how to factorize because this one all involves square root. How to factorize? So if cannot factorize, then you rationalize. How to rationalize? You multiply with the conjugate. You multiply with the opposite of this function here. This function here, you multiply with the conjugate. Conjugate means if it is square root, then minus 1, you put the square root plus 1. You multiply with the square root plus 1. Why you want to do like that? Because we want to get rid of the square root. How to get rid of the square root? You must know this one. A square, a square a square minus b square. B square is equals to a plus b, a minus b. You must know this. You must know this. Okay? You must know this formula. This is not a formula, it's an identity. It's an identity. Mean it is always true. This is an identity. Okay, this is an identity. So a square minus b square is a plus b, a minus b. Or the reverse, a plus b, a minus b is a square plus b square. Okay, so we have here a minus b, a plus b. A minus b, a plus b will be a square minus b square. So far, do you know what I'm talking about? A square, b square, ab. Do you know what I'm talking about? If not, then I explain again.
Teacher, can you
Hmm.
repeat?
Repeat, repeat.
Uh,
Okay. So repeat, repeat. So we are going to look at this identity. This identity say that if a plus b, a minus b, or the other way around, a minus b, a plus b, it will be equal to a square minus b square. A plus b, a minus b is a square minus b square. Do you see anything like this over here? Over here. This whole thing is my a. A minus b. My a is square root of x plus 1. My b is 1. So we have a minus b here, a plus b. Can or not? The a is actually square root of x plus 1. The b is actually 1. So can you see
Okay.
a plus b, a minus b there? Okay.
Yes.
So
Can.
if this is a plus b, a minus b, then it will be equal to a squared minus b squared. So over here will be a squared minus b squared. The a is square root of x plus 1. The b is 1. Okay, now? So I transform the a plus b, a minus b into a squared minus b squared. Now, when I transform it this way, the square root and the square, when they meet each other, they will cancel off. So cancel off, it will be x plus 1 only. And 1 square is also 1. So it becomes very simple. No more square root. And 1 minus 1 is 0. I am left with x only. So 1 minus 1 is 0. I'm left with x only. And the x can cancel with the x at the bottom. So I have only this one left. 1 over square root of x plus 1 plus 1. So now no more square root. I can substitute in 0. When I substitute in 0, 0 plus 1 is 1. And the 1 outside become 2. So the limit is actually 1 over 2. Rationalization, no? You should ask me to teach you right from last year, then your basic not weak, then this one you can follow. Right? But never mind, not too late, we still can catch up. Don't worry, no worry, no worry. Okay, so far, any question or not? No, then we stop here. We have only about 1 minute left. Actually, I have another question to show you. This one more difficult, but never mind. Next lesson, then I show. So far, can you do this using factorization, using rationalization, these two methods? If can, then you do this homework here. Page 33, self-exercise 2.1. Time is running out already.
Okay, teacher.
Okay, no question, then we stop here. Who are they? How many people left? 1, 2, 3, 4. 4 people left, 1, 2, 3, 4. The others don't know where they go. Okay, thank you from Xing Yi. Welcome.
Thank you, teacher.
Thank you.